Ladies and gentlemen, welcome to my live show. This is Ray Fernando, and today we're going to be talking about Apple Intelligence, Sam Altman, and Elon Musk's beef with Apple. If you haven't been following around the Twitter sphere, there's been a lot that's been going on this past week, and I thought I'd cover it because there's just been some crazy things that are happening. So one of the things that happened with basically yesterday at the developer conference was the fact that Sam Altman actually showed up to Apple Park. And that was a really big surprise because there was all these rumors about Sam Altman, doing a deal with Apple and OpenAI and back and forth and so forth, but no one really knew what was happening. And we got a little bit of insight yesterday at the developer conference when Sam Altman was walking around right before the keynote. So somebody had to actually snap some photos on Twitter and was showing Sam walking around. And of course, me being the satire person that I like to be sometimes and kind of clever and be funny, I said, hey, I noticed his blue backpack was missing. And I wonder what could be going on. And basically started to cause a storm on Twitter because people actually believe that the device contains something that can shut down the AI data centers. And it's really interesting because I had jokingly said this to one of my friends over dinner, and it's like, hey, did you notice his backpack was missing? And Ronald, my friend, said, hey, it has the nuclear codes to turn off the AI stuff. And then so I just did a Perplexity search, and it actually said something similar to that. And I actually had to kind of clarify that the post is basically satire and community notes my own self for that. So just a heads up, there's Sam Altman walking around, and then this is the backpack that he used to carry that he no longer carries around. But if you did notice, he's wearing the blue color there. So I thought that was really interesting. Welcome to the stream. I got Manuel online. What's up? Yeah, this is going to be an awesome live stream. We're going to be going through a bunch of deep dives here. Going to be talking about Apple Intelligence. And for those who don't know, let me change to the one camera. I got a really cool setup going on. I used to be an Apple engineer for 12 years, and now I'm basically on my own doing AI stuff. And it's going to be really fun now to talk about what's going on here. I don't have any insights as far as anything internally that I could share at all. I was just doing my own thing. But we're going to look at it from the external point of view. And so I definitely want you to participate, definitely ask some questions. And we're going to make this really popping today. So do you think Apple will release their new AI to the iPhone 15 base model and the 14 Pro? It doesn't appear that way. According to what I can see in the documentation, it's for iPhone 15 Pro and later. And if you're on an iPad, it's going to be the M1's stuff and later. If I were to take a guess, a silly wild guess, I would have to think that it's probably because of resources and being memory and also access to battery and so forth. And so if you're running these things and they take up a lot of energy, then that means your battery will drain a lot faster. And if you have a more capable machine with those 3 nanometer technologies, like in the 15s Pros, you're definitely going to be doing pretty good there. And then you probably have extra memory bandwidth and so forth with the Pro versions that you probably don't on the other phones. I think that's what's probably going to be happening here. So what was really made this event interesting is the fact that during the event, Elon Musk actually ended up tweeting saying that if Apple Intelligence integrates OpenAI at the OS level, then Apple devices will be banned at my companies. This is an unacceptable security violation. So that was really interesting. And he also got community noted. And it also said that visitors will also have to check their Apple devices at the door, where they'll be stored in a Faraday cage. So he's going super extreme here. And I was a little surprised because Elon Musk is an engineer and wasn't really using first principles thinking here in terms of what this means. And he just kind of added this if to the very beginning of it to make it a big stir here, because this actually garnered 83 million views. And basically came back with Apple basically says they run the devices locally on device. And that other tasks that require more complex compute, or Apple determines that they can't do it on device and they need another language model, that they'll actually present to the user a dialogue that will show them a little thing. They can hit, send this to OpenAI and ChatGPT, and they'd be able to do that. So it's patently absurd that Apple isn't smart enough to make their own AI yet, is somehow capable of ensuring that OpenAI will protect your security and privacy. And, he's making these claims very broadly, and it's also getting a lot of people to and retweet and so forth. And I get the freedom of speech here, but I thought he would just kind of maybe do a little bit more diligence in the meme poster that he is kind of showing this as well. It's completely wrong. So I just thought let's just kind of start deep diving into what this is really all about. because, we're sort of like engineers here and stuff, and we can probably figure this stuff out between all of us. So, so if you, for those who don't know, the Apple Intelligence is like I was mentioning there, Emmanuel. If iPhone 15 Pro Max is basically A17 Pro, and then for the iPads, it's like the M1s and laters and stuff, and then for the MacBooks as well. So there's no Intel chips here. Looks like everything M chip and later, and then iPhone 15 Pro later. So that means no iPhone 15 regular, which sucks. Or if you've got the 14, too bad, bro. You're gonna have to drop a pretty penny for this. And by the way, it's coming this fall, but they said it's gonna be in beta. So that means that these features here will actually be dropping and they will be in beta. And so they won't necessarily be like, hey, this is the final version for everything. So that says it's coming to beta this fall. And that would allow you to do some of these things like, basically do intelligent responses and then, writing and communication here. So in this here for like what Apple has actually posted, they posted a couple of things. I was trying to look for an architecture diagram to describe what could be going on. And I think that the closest thing I've been able to find was from the State of the Union. Somebody took a screenshot and shared it, and now it's showing up on Perplexity. So when I'm pulling that up here, what I'm seeing is they have a couple of layers. And for those who don't really understand kind of what's going on here, basically this is like a stack diagram. And what that means is just a way to think of the software in these little smaller components. And as actions occur, it's like you can sort of imagine a little like diagram of what can happen. So kind of think of it, I don't know, maybe like as a map or something like you're looking through. So like if we walk through this experience and walk through like Elon Musk's logic, he would be looking at something like this and be saying, let's just take a look and see how Apple is doing this and how they're actually integrating their phone, this stuff with OpenAI, if they're even doing that at all. And at what point will they be able to do that? So on the left side here, we have this where it says Apple Silicon, and this is on device. So this is basically your phone, and that's kind of what's running there. And then separate to that, on this right-hand side, everything to the right-hand side seems to be the cloud or the server models. And so that's basically separated there, as you can kind of see. And then to the left is basically the stack diagram for the device side as it's kind of stacks on up. And there's like, it says an on-device intelligence stack. So that's kind of what you see in here in this little container. And then above that is like the apps and experiences. So if you're a developer making apps, you pretty much live in this level. And that's why you see these little gray apps that are installed. And that's what you would see on your phone. So in the example that Elon Musk is giving, it's like, how does the system talk to OpenAI? Basically, the on-device, this little intelligence stack, whenever like an app is asking to do a task, for example, use a writing tool to make you write better, it would use this personal intelligence system, which is at this layer right here. And the on-device model will basically determine, like there's just a little bit of orchestration here saying, hey, what is it that we're trying to do? Are we trying to do something with language, or are we trying to do something with the images? And if and that's going to use the image thing, it's going to then use the model that's on device to do that. And if it's doing that and the orchestration determines that whatever task that it's trying to do is not really capable of doing it, and then this on-device intelligence stack will then hand that over as part of the orchestration process to the server models. And so the server models will basically be, taking this task, and then we'll use the various stack here on the private cloud compute, which is also running on Apple Silicon servers, by the way, which has its own security type of things, and then sending that back to the device, and then basically bubbling it back up to the user into the app level to give the answer. And there are also other. I don't think this one actually shows how this is also orchestrating the communication to, because I think this is very specific to Apple Intelligence. But this orchestration, if you think about server models, there's probably a similar. This is private cloud compute OS, private cloud extensions. So I'm not sure if they're doing a cloud extension or ML stack, and this is what we still need to find out. It's like, at what point does this orchestration like hand off to OpenAI, and then like what specific messages are given to OpenAI? And so I think that's kind of what I wanted to use this stream to be kind of digging in on. So I'm Bojini. Hey, guess I'll be upgrading my iPhone. Yes. What phone do you have? I guess. Shout out. Also give a like and subscribe if you haven't done so. If you're watching on YouTube, just definitely give a like, thumbs up. And if you're watching on the stream, definitely add some comments because that kind of gets us bubbled up and so forth and gets us out there. So I definitely appreciate everyone joining the stream. That really means a lot to me because we're out here trying to connect and learn together. So definitely doing that. So appreciate that. So drop like what version of iPhone you got. So if you have an iPhone, definitely do that. If you have an Android, like let me know as well. Like a phone's a phone and I just love technology. So I talk about everything. So there's no like bashing here on either side. I mean, we could if we want to start some beef, but like I'm not that bored. There's just way too much stuff to learn right now. So, but yeah, this is a little bit of interesting about orchestration process we got going on. So Joshua got the iPhone 15 Pro. Yes, same here. And then I have a little case on mine as well. I have this little, because I have a bike that's quad lock basically. So they can, throw it on the bike and so forth. So thanks, Joshua, for tuning in there. So introducing Apple's on-device server and foundation models. So in here at the developer conference, they talk about the overview about a 3 billion parameter device language model and a larger server-based model available on private cloud compute and running on Apple Silicon servers. Have been built and adapted to perform specialized tasks efficiently, accurately, and responsibly. These two foundation models are part of a larger family of generative models created by Apple to support users and developers. I love saying this stuff. Like, reading is kind of fun. It's like, say it out loud. Looking forward to the fact-based look at what they showed. Yeah, I agree. Yeah, I think we should just kind of start digging in the facts here. Pixel 7 Pro, let's go. Let's go. I'm not familiar with the Pixel 7 Pro, but I'll have to look at the generations and see what that kind of lands us. Is that like a 2020 phone, 2021 type of thing? Let's see. Okay, so these two foundation models are part of a larger family of generative models by Apple to support users and developers. This includes coding model to build intelligence into Xcode, as well as diffusion model to help users express themselves visually, for example, iMessage apps. So that's a little bit of what we saw here. They're talking about the on-device language model and the on-device basically image model. That's kind of what they're saying in that here. Okay. We look forward to sharing more information as soon on this broader set of models. Okay. I think this is where they're going to be doing their thing. Years. Yeah, thanks, y'all. Yeah, thanks for the support. Yeah, this is going to be like a nice, chill stream. Think about like getting your coffee, chilling. We're just going to like talk about the paper and what they've been discussing and just go a little bit technical and deep. And there's a lot of stuff I don't know either. So I'm just going to be using Perplexity and I'm going to be using everything that we have on our hand because this is the internet and there's a lot of smart people out there. So we're going to ask them as well. And if you're on the internet and you're smart, definitely chime on in because I need your help with this. Yeah, what's good, homies? Yo, what's happening? Definitely appreciate all the love on the stream and stuff. So let's just hang. So our focus in responsible AI development. So Apple Intelligence is designed with our core values at every step and built on a foundational of groundbreaking privacy innovations. That's definitely facts. Additionally, we have created a set of responsible AI principles to guide on how we develop AI tools as well as models that underpin them. So they empower users with intelligent tools, represent our users, design with care, protect privacy. Right. So they are talking about their architecture here. Okay, responsible AI principles inform all steps. So they basically get data, pre-processing, pre-training, post-training, optimization, and Apple foundation models. And then this is what they have is like adapters and so forth. Okay. Pre-training, our foundation. Okay, so they basically have laid out the document from at these phases and kind of explain a little bit in more detail. It looks like how each of these phases how they basically have generated this model that we've been looking at here for the on-device intelligence stack. This is really fascinating. Okay. Yeah, there's a lot that's going on here, but we're going to try to figure this out. Our foundational models are trained on Apple's AX-Learn framework, an open source project we released in 2023. It builds on top of JAX and XLA and allows us to train the models with high efficiency and scalability on various training hardware and cloud platforms, including TPU, and both cloud and on-premise GPUs. Okay, so we use a combination of data parallelism, tensor parallelism, sequence parallelism, and fully shared data parallel. Shared data parallel, yeah, FSDP. Bruh. Who comes up with these names? FSDP? Come on. To scale training along multiple dimensions, as well as data model and sequence length. Okay, I got you. That's a lot of word salad. Let's figure out what this means. AXLearn Public, an extensible deep learning library. So this is their GitHub that they linked in their thing. Yeah. Yo, do you have the DP though? You know what I'm saying? I got the ASDP. No. I'm cool. Let's see. Okay, getting started. It's a library. What the heck's JAX? Okay, high performance array computing. So it's a Python library for accelerator-oriented array computation and program transformation design for high performance numerical computing and large scale machine learning. Yo, today I learned. I appreciate the comments. You're such a soothing voice. Thank you. Yeah. Yeah. Homies support homies. HSH. Yeah. I got the voice. Let's read through it. The reason why I'm doing this also, part of the whole mission here is I grew up having severe dyslexia and I've worked a lot around it. So reading out loud and hearing my voice helps me with the reading. And so if it helps you, hey, stay tuned in. And if it doesn't, whatever. It's a live stream. So come in and come out whenever you want. I'm here. It's free. It doesn't cost you anything. And we're really, for me, I could play this back later over and over again. So really, this is just an archive. And so y'all hanging out, drop some comments. We're just going to do this because why not? I'm trying to learn. There's a lot going on here and we can learn together. So so far, we basically have been going into Apple Intelligence, going a little bit more about the on-device model. And we're at the pre-training stage and they dropped this fancy word called AXLearn framework. And they apparently dropped it in 2023. And so far, it looks like it builds on top of JAX. And JAX, we just learned, is a high-performance array computing thing that they've used like a Python library for, which makes sense because that's probably their purpose. And then XLA, which allows us to train models in high-efficiency scalability. So that's an interesting thing here. So let's I just want to really quickly look and see what this JAX thing is because they have a quick start. So building on JAX. So it's the Flax in Haiku. Okay. This is fascinating. Quick start. All right. So you pip install it. Okay. So for an NVIDIA GPU. Okay. I got you. They do that. So in here, I think they use Apple Silicon. So they didn't use the CUDA core. That's interesting. So JAX is NumPy and they return a Lambda. Okay. So this import is similar to typical NumPy programs, including NumPy style array. Okay, so this is probably how they decide how they scale the compute. Fascinating. Okay. Yo. All right. And then that was the JAX framework. Yo, this Apple's and then XLA. That was the other question I had about. So it's an accelerated linear algebra. It's an open source compiler for machine learning. Got it. So the linear algebra appears to be a common theme for machine learning because of the way that they're doing their number compiling thing. And XLA compiler tasks takes models from the popular frameworks such as PyTorch, TensorFlow, and JAX and optimizes the models for high performance execution across different hardware platforms, including GPUs, CPUs, and ML accelerators. For example, in a BERT ML perf submission using XLA with Volta, 8 Volta V100 GPUs achieves the 7x performance improvement and 5x batch size improvement. So it looks like these are all part of the OpenXLA project. And so, yeah, that's awesome. So the key benefits is build anywhere. XLA is already integrated to leading ML frameworks such as TensorFlow, PyTorch, and JAX. JAX, which we saw earlier. It supports various backends, GPUs, CPUs, ML accelerators, maximize scale and performance, eliminate complexity, and future ready. So that's cool. That's awesome. Dang. Go Apple. This is not like a fly-by-night thing, by the way. And if you think about this a little bit, people are like, oh, Apple's late to the game or they're dropping stuff. Just to set this type of stuff up, it takes a long time. This is not like, oh, snap, we got to do ML, like figure out this type of research in like the next month. Like, let's just figure this out. Like, Have you seen the documentation on here? Some lonely developer and team have to like, oh my god, let's go ahead and figure this out because like this is not Apple specific. So yeah, this takes a while. I mean, and even if you are experienced, just figure out all the very specifics that are going to work for these components, and then you're throwing them on servers and stuff. Yeah. There's like people get paid lots of money to figure this stuff out, but I'm just trying to figure out what they're saying and what some of these words mean because it's going to get tossed around a lot. And at least I have a little bit high level understanding. So AX Learn library for deep learning. All right, cool. So this is pre-training. So this is in this stage. And then we're going to have post-training. So after that, and then how they optimize and basically how they land into the models on device. Because from the information that I sort of am gathering now is like, it's so important to, like when you make a meal to cook at home, like the better ingredients you have, like the better tasting the food it is. So for example, if you've ever if you're into like cheese and stuff and you're like have a grilled cheese sandwich, it actually matters how old your cheddar is. So if you have an aged cheddar of like 3 years, it's going to taste amazing. So if you get like a 5-year-old aged cheddar and make grilled cheese on it, it's going to cost you more, but it's going to be like baller. It's going to be like flaky, crystally and stuff inside. And like, there's a whole level of cheese that you didn't like, never knew. But if you get like an over-the-counter Kraft cheese single and throw that on the sandwich, I have like a epiphany for you that there's like a whole nother level of cheese. And so data in a similar way here is kind of the same thing. So like the types of data and what you're doing in the training, how do you set up all these parameters and like shove things in to be as efficient as possible? All these steps and the details matter because the output of what you want and efficiency for power and all these types of things and these decisions that the engineers make really does matter as far as what the output you're going to get. And then like what that sets you up for the future as well. And the other part of it too is that this is not a one-time thing. They're going to have to repeat this process over and over for every release of every software in perpetuity. And so what that means is that as they get new data in, as the world is changing, they'll have to retrain these models, using these similar techniques. So they have to kind of get everything all set up and done that as well. So just kind of a heads up there. So it says that they train their foundation models on licensed data. That's another thing that I didn't hear mentioned in the keynote or anywhere else. I think they just said, we have these models. So that is an interesting deal. So that's something you can tell your friends today. If there's anything you remember, today you learned that Apple trained their foundation models on licensed data. Yeah. OpenAI basically just said, hey, we're just going to grab everything from the internet. YOLO. Midjourney, the same thing, So that's huge. Including data selected to enhance specific features. See, this is what we're talking about the cheese thing. This is where it comes back. So they basically got specific data to get specific features that they wanted, as well as publicly available data collected by our web crawler, Applebot. Ooh, okay, let's go. This is now we're cooking. Let's go. Web publishers have the option to opt out of their use of the web content for Apple Intelligence training with the data usage control. What does that look like? Today I'm learning about Applebot. So OpenAI, hey Flo, how's it going, Mary? Creative Mary Ellen Schrock. OpenAI is in a deal with Shutterstock for 6 years plus generating, thank you for the insight, AI training data. That is super awesome. Yeah, for those who don't know, if you haven't followed Flo on X, got a lot of cool creative stuff going on with the whole image generation and so forth. Like if you haven't had a chance, definitely go check Flo out. And yeah, definitely appreciate everyone just dropping comments and stuff. That's super helpful for our community as we're kind of going through here, just learning on the fly, learning a little bit more, getting in the weeds of things, of the technical details, and then trying to pull some of those things out and trying to, surface them because, today could be more technical and like tomorrow we can kind of synthesize a little bit more of like what we've learned and put together and then kind of speak more intelligently when people make really broad claims on like, the intelligence thing, Apple's just, going to farm your data. It's like, well, actually, no. They're very disciplined about what they're doing, and it's just not a fly-by-night operation as we're just even starting to peel back the first layer of the onion of many. So definitely. Of course, we're doing all our best to keep up in this space. Yeah, for sure. Yeah, today's definitely going to be much more like deep, peeling the first layer of many, but yeah, just approaching it from my experience a little bit as an engineer. And there's a lot of stuff I don't know because I'm still trying to learn stuff about AI. So we're learning together. So that's what it's all about. At FLO Creative. Yes. Cool. So Applebot. So Applebot is something that looks like they have their own. Apple has their own version of a web crawler, as we learned today, and it looks like they go and search things, and it includes user experiences for like Spotlight, Siri, and Safari. So today, if you ask Siri about like sports scores or doing different things, it's probably going to get you that information through the Applebot. So enabling Applebot in robots.txt allows website content to appear in search results for Apple users around the world. This is interesting. Does Vercel do this? Vercel, let me see, Perplexity. Because I launched my apps using Vercel. Vercel, Applebot, support, robots.txt. So this is the way that I use Perplexity, perplexity.ai. I love this thing because basically it's an AI-powered search, and it uses AI to not only, like, it's better than Google in a lot of ways because it's like a Google because it does a search, but it searches like a bunch of resources. So it uses, for this search, it used 13 different sources. It scanned all these, Stack Overflow, GitHub, developer forums, YouTube videos, all that stuff, then tries to understand the question that I'm asking, and then also like puts together a little summary of the answer. So this is amazing. So this is going to be super helpful. So let's see, to ensure, let's see, Applebot, the web crawler used by Apple products, should crawl. Yeah, because it respects the robots.txt file, which Google's what are you using, and this is what these frameworks already provide. Yeah. So, okay. Yeah. My stuff is already doing this, which is awesome. Yeah. Okay. We're Gucci. Sweet. Interesting. So Applebot also comes from a very specific source. It's basically the DNS.apple. It's like star, whatever the IP is, .apple.com. So they'll have like a specific reverse DNS type of thing here. Okay. So if you're ever seeing this show up in your web traffic, then you know it's basically from Applebot. Okay. That's cool. Today I learned. So customizing. All right. That's cool. So this is their pre-training. So this is part of the stuff that goes into their training and stuff like that. Yes. Yeah, we are so Gucci. Yeah. We never use users' personal data and user interactions when training our foundation models. So that's really interesting. So they don't use users' private personal data or user interactions. Okay. Like, yo, this is huge. So the big deal, and this is what I hear a lot on Twitter Spaces right now. So like tell your Twitter Spaces friends who are going off and like, Apple has the next control of things. Like, they're never use user data. So like whatever you're doing on your device, Apple's not going to use it. Or your interactions when training these foundational models. So that means like whenever you launch an app, whatever you're doing on the device, like Apple's not collecting this data to use to train their like these little models. And the foundational model that we were talking about are these ones for basically language or images on device. So this is the secret sauce. This is kind of like what OpenAI has on the server. But OpenAI, like, they train on everything. So like anything they get access to, like, besides that's like licensed and stuff, as a user, whatever questions you're asking, whatever stuff you're saying in the voice, they're, OpenAI is training on that. And Apple specifically says for their model, they don't train on that. So that's just a pretty big heads up right there. Like, this is a really big, I'm going to write this down because I'm going to start keeping notes because this is really, really big. I think we have to keep this somewhere. So notes. Oops. Here we go. Cool. When training our foundational models, we apply filters to remove personally identifiable information like social security, credit card numbers that are publicly available on the internet. We also filter profanity and other low-quality content to prevent this inclusion in the training corpus. In addition to filtering, we perform data extraction, deduplication, and the application of a model-based classifier to identify high-quality documents. Wow. Okay. So this is really great. So basically, their model that they have doesn't have this information in it, so it just can't like randomly generate someone's type of thing. This is interesting. Cool. Post-training. So in this step now, we're in like the post-training. So this is pre-training. This is before they put that stuff onto the computer and onto the cloud to do the training to build the model. And so post-training would just be now after it's gone through the computer, what do they do with this like model thing that's been generated, and what's the next step after that, and what are those details? So in this step here, basically, now they've kind of generated the file, and then now they need to do some stuff after the fact. So in this case, like in our cooking analogy, it's like now you put it onto the grill cooked the thing, now you take it off the grill. You just can't eat it from the grill. I mean, you could, but like we're trying to be fancy here, and this Apple's fancy. We got to plate it. We got to do the things. We got to, before you serve it, you got to like wipe off all the extra butter that's on the side. Maybe not. I don't know. Like it's just whatever your style is. So the post-training, after the fact, it says we find that data quality is essential to model success. That's a good keyword there. So we utilize a hybrid data strategy in our training pipeline, incorporating both human annotated and synthetic data, and conduct thorough data curation and filtering procedures. So basically, they do a couple of things. They basically go through and annotate things by hand with like humans, I guess engineers in this case. And then synthetic data, basically it looks like they will generate data to kind of support some of these models as well. And they have basically developed two novel algorithms in post-training. So it looks like they do two different things. A rejection sampling fine-tuning algorithm with teacher committee. What does this mean in English? Let's ask ChatGPT. Right? OpenAI.com. Okay. What? Yeah, let's just... What? Okay. Explain this to a 6th grader. All right. A rejection sampling fine-tuning algorithm with teacher committee. So, okay, imagine you have a really picky group of teachers. That's right. Each with their own idea of what makes a perfect drawing. Okay. You're trying to draw the best picture possible, so you decide to use their feedback to improve it. All right. So you draw a picture and show it to these teachers, right? And whatever your picture is. And then a teacher looks at your drawing and decides if they like it or not. Okay. So they basically just give like a, And if most of them say it's good, you keep the drawing. And if not, you throw it away and then you just do a new drawing. So rejection sampling is like this process. You keep making drawings, or guesses in this case of the algorithm, until you get the one that's most of the teachers give approval of. So this helps you make sure that your final drawing is really good because it has passed the test of many different teachers. Yo, this is like, yeah, that's so crazy. Hassan, I found the cheddar was their semantic index. Yo, that's a really good one. I like this. Y'all keep coming with the comments. This is really gold. I'm liking this. So that's really interesting. So in a rejection sampling fine-tune algorithm with a teacher committee, the algorithm keeps trying different solutions and only keeps those that the committee or group of teachers thinks are good. This way, the algorithm learns to make better and better decisions. Boom. So this is, by the way, we're still at the post-training step. So that's one of the two novel algorithms that Apple has developed after the model has been trained and comes out. They basically give it this rejection sampling fine-tune algorithm with teacher committee. So it sounds to me like the committee is given answers, or maybe a question is generated and the committee is given answers, and this committee of X amount of people give a thumbs up or thumbs down. And if enough of them give a thumbs up, it stays in that little context. And if a bunch of them give thumbs down, then they basically throw that result away. And that's basically what they're using to do. That's just one of the two here. Wow, this is cool. So and then a reinforcement learning from human feedback algorithm with mirror descent policy optimization and leave one out advantage estimator. Bruh. Like, okay, let's do the same for this. Do the same for this. Okay. Let's go. I mean, might as well ask ChatGPT because they're super helpful, right? So this is the way that I use AI to help me learn, and hopefully you can get something out of this too. And just by doing this, we can learn together. So yeah. All right. So imagine you're playing a video game. So we're talking right now about a reinforcement learning from human feedback, it's RLHF algorithm with mirror descent policy optimization and leave one out advantage estimator. So we're going to go a little bit deeper on this. So imagine you're playing a video game. Okay. And you have a coach watching you play. Okay. Your goal is to get the highest possible score, but you're not sure what the best strategy is. So your coach gives you tips based on what they see you do right and what could be improved. I got you. So the reinforcement learning from human feedback part is like getting advice from your coach. So every time you play around in the game, you get feedback and you try to use that feedback to do better next time. I got you, fam. I totally got you. So now imagine you have a special method to practice and get better called mirror descent policy optimization. Hold up. We got to cook here. Think of this like looking in the mirror while practicing. The mirror shows you what you're doing and helps you adjust your strategy bit by bit, making small improvements each time you get closer to the best strategy. So literally like every step of the way, you're like making the improvements because you can watch yourself in the mirror. Yo, that is the mirror. Okay, I've never heard this term, and like this is just blowing my mind around. The mirror descent policy optimization. That's fancy. Y'all come up with these fancy words. Lastly, leave one out advantage estimator. Okay, so like, did you realize how much was just packed in this just like word salad of like a sentence? I mean, I understand now why this is cool. So the best part is if I can re-explain this back to you, like in a casual conversation, like we're just chilling, like, yo, last night I was just playing out with that leave one out advantage estimator, but what really helped me was that mirror descent policy optimization, because when I was, playing the game, like it just got me the next step. And now I just make threes like Steph Curry with a shot, boy. Yo, hit the comments, hit the likes, hit the fire emojis if you got the shot. if you're kind of following, if you're picking up what I'm putting down, because this is heavy right now. This is, take a little sip. And there's a lot of education going on here. So, all right. So lastly, leave one out advantage estimator is a fancy way of saying that while you practice, you try to figure out how much better each move you make is compared to what you hadn't made that move. So that's super meta. Okay. So it's just a leave one out advantage estimator. So you are trying to figure out how much better each move you make is better compared to the next move. So like, I guess the best way to think about this is like maybe a chess game. So if you like are trying to figure out, okay, I can make this move, but if I make this move, how much better is it going to be compared to where I was going to go? And then that's kind of where you make that, leave one out type of advantage. But here are the twists. You do this by imagining what could have happened if you left one out of your moves. So it's like replaying a part of the game in your mind and skipping one action to see if skipping it would have helped you get a high score or not. So instead of saying, that move I was going to make, let's just not do it. Let's just continue with the move that was, this other, the other move that I was going to make. I was like, let's just not do it. Let's just go down this path and see if it gets higher or not. And then if it does, you just stick with that one. That's crazy. So putting it together, you're playing this video game, your coach gives you feedback. You practice by making these small adjustments while closely watching the mirror. And then you keep thinking about whether each specific move really helps you get a higher score. And so this helps you learn the best way to play the game. So they use those two algorithms, the mirror reinforcement one, along with the, I think I might have deleted that. Okay. The rejection sampling fine-tune algorithm with the teacher committee, which is the teacher committee, if you make the drawing and all the teachers give the thumbs up, it stays. Or if they give a bunch of thumbs down, that thing gets removed from the data set. Yeah. So this is the post-training step. So putting this a little bit back all together, going back a little bit. So we started with the data, and the data Apple says like, yo, we don't train with your stuff that's on device. We don't really go do that stuff. You keep your, whatever you do with your boo and whatever other things, imaginary animals you got online. That's you. You do you. Like Apple's like, we don't see that. No, we're not even trying to be about that. And it's like, that's cool. And then they basically get this data and like kind of, set up the kitchen, right? Getting ready to cook. And then they do the cooking. And then they do the special process, like we're in the pre-training stage. That's where they set up at the kitchen. And then the post-training stage is like after the model, after we got the grilled cheese. And now we're melting and just enjoying this with this like specially handcrafted 2 novel algorithm post-training thing with this like little thumbs up thing. Everyone's giving the thumbs up with the, with the drawing, and then the reinforcement learning from human feedback, mirror algorithm, descent policy optimization, and leave one out advantage estimator. Whew, man. And this is just post-training. We haven't even made it to we're still trying to make this device model. So we find that these 2 algorithms lead to significant improvement in the model's instruction following quality. So that to me is really interesting. The fact that this is such a tiny model that can run on device that does like basically the language or the image modeling there. It's a 3 billion parameter. So that's really, really tiny. The rumor of OpenAI's model that runs on the server is like 1.6 or 1.7 trillion parameters. And we're talking like trillions of parameters that needs like all this crazy infrastructure and all the GPUs of the world to be running to just have it available for us in ChatGPT, where Apple's like, yeah, we got 3 billion parameter on device. And they're like, it probably doesn't even use that much energy because we've done these really cool techniques. And that's just us, Apple. That's so crazy. Yeah, they're cooking. This is really cool to see. So that's the post-training. And then, so this is post-training. So post-training is literally like they're throwing like 2 crazy people like at it, like imagine like if you had like 2 trainers that are super buff. One's like showing you a mirror and telling you, it's screaming at you at every step of the way, saying, "Yo, you need to keep doing this. No, move that. No, it's just like literally helping you, and then also like in your brain doing the Jedi mind tricks thing, like getting you to think about things, and then you have like a committee of people at the same time also watching you. And like after you finish your results, you're like, is this good? And they're just like, nah, go back at it again. Go make another shot. Dribble and do that again. Take another step back. It's like, but I made it swish. It's not good enough. Go back again. Yo, this is some crazy dojo stuff. Yeah, this is mad. So optimization side. So damn, in addition to ensuring our generative models are highly capable, we have used a range of innovative techniques to optimize them on device and our private cloud for speed and efficiency. So we've applied an extensive set of optimizations for both first token and extended token inference performance. We've applied an extensive set of optimizations for both first token and extended token inference performance. All right, let's ChatGPT help me cook. So this sounds like a great approach. By focusing on optimizing both initial response time and the ongoing processing speed of your models, you're enhancing the user experience significantly. This kind of optimization is crucial, especially when deploying AI solutions that need to perform well in real-time environments and when using devices with limited computing power. Great job on implementing these advancements. I mean, I didn't do it. I just copied and pasted this little text up in here, but I guess so. Yo, I mean, man, this is nuts. So both the on-device server models used group query attention. We use shared input and output vocab embedding tables to reduce memory requirements and inference costs. These shared embedding tensors are mapped without duplications. The on-device model uses vocab size of 49K, while the server models use a vocab of 100K, which includes additional language and technical tokens. So basically what they're doing is that they've tried to reduce everything as much as possible to use as little energy as possible to like query the models, get the responses back, and so they can be fast enough to do things. So one of the problems sometimes you've seen with ChatGPT is like it takes a long time to spin these things up and then get the stuff back. And then some of the problems that people are seeing right now, like with the Humane AI pin and also with like the rabbit models, is that like there's a lot of time that has to happen for this stuff to go out in like on the device. The device has to make a decision about what to do, and then it gets sent out into the internet, and then that cloud server does its processing, and then it comes back onto the device and then starts streaming back the response. Like there's a lot that goes on there. But what Apple is saying that they're doing in this like last phase is that they're optimizing like every little detail here about how the models are working, and like, you know, these decisions and like doing these little engineering optimizations so that they can be as fast as possible and like as accurate as possible, so that they don't have to do this type of thing. So yeah, AI knows you're streaming. Yes, Apple Intelligence for sure. Yeah, definitely appreciate the comments. Yeah, we're just like totally nerding out right now on like Apple Intelligence, because like our bro, Elon Musk says like this is kind of how it works when it's clearly not the way that it works. And, the community notes are like, hey, like, all these types of things. But I just thought we'd just dig in firsthand a little bit and go into the details of like, how does this stuff really work? And is it really what it is? And most people don't even, I've not heard anyone on any stream that I've watched or any YouTube video like drop any of this knowledge that is literally on Apple's website. Right? I mean, we found out already that like Apple does not train on your user data, like, and they're not even trying to do that. You know what I mean? And it's like they do these cool optimizations. They've done like a lot of work to make these things as efficient as possible. They have like a very strong intent for what they're doing, and it's pretty clear that they're just not willy-nilly just, we're going to send all your data to OpenAI. It's like that's not how this stuff works. So yeah, we're here trying to spread this message, trying to learn together, and like you're here because you're curious and you're awesome, and I really appreciate that. So if you haven't done so, thumbs up, like, subscribe, bell. We got the whole stream thing going on. I'm just going to be doing this because I can, and I used to be an engineer at Apple actually for about 12 years, and I'm now basically on my own trying to learn AI and learn some of this engineering stuff. And also have been recovering from long COVID, which has been really crazy. So learning more about this is kind of helping me, get my brain kind of wired. And reading out loud is super helpful for me, especially with like dealing with severe dyslexia and trying to rebuild my brain chemistry here again. So I definitely appreciate all the likes and follows and stuff. And if you haven't done so, definitely check out rayfernando.ai. And on there, feel free to just drop in your email. I don't spam you. This is literally just me and you. And so that we can stay connected. And I should probably just start dropping some of my knowledge on here as far as like what we're covering today on the stream, because I think that could be super helpful. Because there's a lot of really cool tidbits we talked about today, and I would just love to have them documented. Yeah, so previously I've done some like live streams, like unboxing tech products and stuff. And I have a show that I have going on every Friday on like at noon. So on Friday at noon, I'll basically have a show with my co-host. His name is Ronald. We used to have a show called AI Mondays, but now we basically, we do different things. Before I've done like a live stream with him unboxing the device. And then I've done myself like live streams as well, like unboxing the AI pin. And then this falls like I, run into various numbers of issues. So if you're totally into that, if you're like a tech enthusiast as well, that's kind of what I do here. Basically talk about tech, talk about different things. As I get devices, go into that. Because I'm an engineer, I like to go a little bit deeper than a lot of people. I also very curious and just want to ask a lot of questions and want to try to find the sources for these things, just so I know how these things work. So yeah, if you want to vibe with me, I try to do that. And feel free also, like, since this is our live stream together, just drop a comments, whatever you drop, I try to feature them and slide them in. I was having some issue, I think, with Twitch earlier, where whatever I was whenever people were dropping comments, I couldn't see them. So I don't see those currently in the stream at all. So yeah, so the more detailed, the better. Thank you. Definitely appreciate that, VM. Super awesome. Yes. So for on-device inference, we use low bit parallelization, a critical optimization technique that achieves the necessary memory, power, and performance requirements. So to maintain model quality, we developed a new framework using LoRa adapters that incorporates a mixed 2-bit and 4-bit configuration strategy, averaging 3.5 bits per weight to achieve the same accuracy as uncompressed models. Wow. So that's interesting. Additionally, we've used interactive model latency and power analysis tool Talaria to better guide the bitrate selection for each operation. We utilize activation quantization and embedding quantization and developed an approach to enable high efficiency key value cache upon our neural engine. So like with this set of optimizations on the iPhone 15 Pro, we're able to reach the time to first token latency to about 0.6 milliseconds per prompt token. So a generation rate of 30 tokens per second. Notably, this performance is attained before employing token speculation techniques, from which we will see further enhancement on the token generation rate. Okay, you know what this means? Remember that question we had earlier about why did Apple not include other devices in their like Apple Intelligence compatible type of thing? That's why. It's literally at this specific phase, for the optimization phase, that they discovered like this is probably the bar that they should be at in order to have like the best response without feeling too laggy. Like Apple said, this bar is not going to go any lower than what it is. And so the iPhone 15 Pro Max gave these benchmarks. And so the other devices, imagine waiting 1 second just to do like this thinking. That's like, so 0.6 milliseconds. That's, 0.6 of a second. It's fast, but not fast. But at the same time, depending on what you're doing, it could be fast or like not noticeable. And the generation rate of 30 tokens a second, it's basically what gets streamed across with your text and so forth. It's interesting. It's very, very interesting. So like I could see why an iPhone 14 isn't on the books, because it would just probably be like 1.2 milliseconds, and then the other ones may not. And then also we're talking about like power and stuff too, because those chips aren't really that efficient for those types of tasks. So there's a couple of reasons. There's definitely like, wow. Okay. So yeah, so that's basically there. And then, so there's these adapters that are going into this Apple Foundation models that are part of this last part, which says adapters. So this is where at model adaptation. So our foundation models are fine-tuned for users' everyday activities and can dynamically specialize themselves on the fly for the task at hand. Oh, that's cool. So that was my other question. A lot of times when you train a model, you have to train them from very specific things. So like if you're doing image generation, it only can really do that very well. If you're doing stuff for like text and other things, it does that very well. But like, what if you make an app that does coding and then incorporates both of them? Like, how is this going to figure it out? And it looks like their models are fine-tuned for these like everyday activities. And looks like they adjust themselves on the fly. So we utilize these adapters, small neural network models, that can be plugged into various layers of the pre-trained model to fine-tune our models for specific tasks. So for our models, we adapt the attention matrices, the attention projection matrix, and the fully connected layers in a point-wise feed-forward networks for a suitable set of decoding layers of transformer architecture. So by fine-tuning only the adapters, the original parameters of the base pre-trained model remain unchanged, preserving the general knowledge of the model while tailoring the adapter layers to support specific tasks. So the specific tasks they have here are summarization, proofing, proofreading, mail replies, tone adjustment, refining, query, friendliness, urgency. So that's pretty cool. It's a really cool way that they've done this, basically to overlay it onto like the base model without changing the model very much. And so what a lot of times people do are they like do these fine-tuning type of tasks to make the model a little bit more compliant. And sometimes what they're doing is that they're changing the behavior of the base model. So the base model may now start to do a different type of output. And that could be pretty bad for, especially in Apple's case, if that's the case. But they said, hey, there's probably a better way to do this. And so we're going to do this whole adapter technique. Well, it sounds like they've done a lot of hard work, as we've already understood earlier, for how they get the data, how they put it onto the device, what they do afterwards with the data, the device, right? Because afterwards, they have this to type of very specialty approach where they do those drawings, right? Like an example, they're drawings and the teachers are giving the thumbs up. And then the other part where they're doing the training and they're like literally watching every step of the way. While also doing that, they're getting into the head of the person who's doing the training and having them think about their steps and then removing those steps and seeing if you score better or not, like all at the same time, right? So like that's already a lot of work that's just making that base model. And since it's already so good, making this little adapter layer makes it more adaptable to the environment. So as the environment is changing, as people are doing different types of things, it's still tapping on that really good base knowledge there that lets you do other things. So I guess let's kind of like pick this up a little bit and kind of throw some cooking on it because I love to cook. Or I'm learning how to cook, but that's kind of the thing. It's like if you have like chicken and you have like a really good chicken and you've spent all this time to marinate it, like if you want to make enchiladas, like you would just like strip the chicken bits off and then like start putting them in tortillas and like start rolling up the tortillas and putting some cheese on it and then like throw it in the oven with some sauce and like bake it. And then you get some solid tasting enchiladas. And why does the enchiladas taste so good is because you got good chicken, you got some good cheese, and you got some good ingredients, right? So like if you already have the good ingredients, why mess that up, right? But sometimes it sounds like other approaches for these types of things to be like, well, we want to make the enchiladas, like we kind of have to like change up some of the ingredients and let's just do these other things because of their limitations. And so that's kind of the difference here that could happen. And I'm just totally making this up, but it could be that it's maybe a little bit more nuanced than that. But it sounds like the adapter approach is like the more novel approach that they're doing here that basically allows this adaptation to happen without changing this core part down here. Which is what they're sort of relying on for that type of thing. So that's interesting. Performance and evaluation. Wow. So they're comparing these to the other smaller models that are running, like the Phi 3 Mini. I think it's from Microsoft. So basically it looks like it sort of performs on par or to the same result as these other models. The other thing is that while the performance... So here's the other special kicker that people may not do or may compare a little bit differently here is that people are going to want to compare like how does it perform against X model? But what we learned earlier in this like pre and post training phase is that Apple has done a lot of steps along the way so that it works very specifically like for their specific, architecture. So you could get the same results for like benchmarks and performance and like, basically, when I say benchmark and performance, I mean like, if you make this drawing of some like dinosaur and you show it to like 5 different teachers, if they all give the thumbs up, that's like the score right here. So if you have like an 87% score and then you have something else that's 70% score, you're always going to take the 80 something percent score. But another thing that isn't measured is like efficiency and power. And that's kind of something that Apple tends to specialize in. And so while you can get a good score, how much energy and how much power does it take? Is it really slow for the user experience? Are the users going to want to like throw their phone out the window, or is their phone too hot to use and they don't want to use it anymore? It's like, what's good about having a great feature if it overheats your device or if it uses up a lot of energy? And this is where Apple's like really cooking, and they're just like, well, we know that we can do a lot, but since these devices need to be in people's hands for a long time and do all these types of things, that user experience needs to be really good. It needs to be really fast. It's 0.6 milliseconds for some of these operations. And they're also saying, we can't run this on this lower powered phones or like the older phones because it's not going to be up to par. So they've said like, this is going to be our baseline and it's got to at least operate this way and better. So that's like a little bit of thing just to keep in mind. That can be misleading is like you may want to ask yourself like, what's the user experience like, even though the model doesn't run, as a higher score on like an non-Apple device, right? Like one person can say, well, like on Android, I can run the bigger model and do whatever. It's like, okay, tell me what happens 30 minutes after you're running that model. Like how slow, like can you even take a phone call? Like, if it's using up all your resources, are you even getting all your messages on time? Like, like there's just so much optimization and stuff that has to happen at the operating system level that Apple's extremely picky about that they're not going to let these developers just run the muck on it, and that's why they're really strict and very thoughtful about what they're doing. And it's very clear just from reading this documentation from Apple's website, from machinelearning.apple.com, about this specific type of thing and how they did it, and then like why it does what it does and why it's basically so cool. I don't know. I think to me that's very fascinating. It definitely speaks volumes to the teams and the people who've been working on this technology. It's definitely not like oh yeah, we need to figure out an ML strategy by like next WWDC type of thing. But you can tell that this is probably something that's been cooking for a while, and seems to be sort of ready-ish to be, enough to have all this data and all these different types of things to be available. So I wonder if these people even went to sleep. There's just so much stuff that's going on. This is nuts. So wow, this is human eval for output harmfulness. So on-device violation rate. So that's interesting here too. So like what they've done is basically have got the outputs for some of like the harmfulness, basically things that would be harmful responses that you would get from the model. And they actually found that all the stuff that came from the Apple device was like significantly lower. I mean, look at Mistral. So like Mistral is a 7 billion model. 44% of the time, the violation, like if they fed it some harmful stuff, it would basically come back and say like, yeah, this is like pretty harmful. Like we have to know what is harmful and what they deem as harmful. But like the fact that the stuff on Apple's devices definitely don't come back as harmful, that is super impressive. OpenAI is literally trying to figure out this problem right now so hard. And Apple's like, yeah, we do this on device. Like this is where we're at right now for our small models, right? It's not the big models, but still. And even on the server, like this is super impressive. This is crazy. This is interesting. This is really interesting. How do they... Okay, so let's just figure out this evaluation here. So we use a set of diverse adversarial prompts to test the model performance on harmful content, sensitive topics, and factuality. So we measure the violation rates of each model as evaluated by human graders on this evaluation test. So with the lower rating being desirable, both on-device and server models are robust when faced with adversarial prompts, achieving violation rates lower than open source and commercial models. Bruh. Yeah. Breaking. Elon Musk drops breach of contract lawsuit against OpenAI. Oh, for real? For real? Let's see. Perplexity. Elon Musk lawsuit. OpenAI. Breach of contract. Let's see what he's cooking. Thanks, VM, by the way. You've been so great about commenting and kind of keeping me up to date on things, so this is super awesome. Let's see. So, like, why is he... When did this come out? June 11th. Yeah. 229 PDT. Oh, dang, this is super breaking news. VM is on it. Wow. There were some problems with Musk's case. So he's basically saying that Musk is alleging that OpenAI breached the contract that does not exist. It's simply not a thing. The complaint makes reference to the founding agreement, but no such founding agreement is attached as an exhibit. And the breach of contract claims admits that founding agreement is basically a vibe everyone caught in some emails. Yo, so okay. Hold on. Let us cook. VM, thank you so much. Like, so you're telling me that some billionaire filed a lawsuit because of some vibes in an email where he thought that there was like a founding agreement about a thing and like OpenAI and like caused this whole stir for, I don't know, like many months. And then they're just like, yeah, we're just going to drop this thing because it's like, there's no actual founding agreement even presented in the evidence. So like what that means is like, you have an allegation, you say like, hey, This is like a breakup. This is like a breaking up with an ex, and like your ex is claiming that you did something, and like you're like, huh? I don't understand. Like, show me the evidence of what you're claiming to be. And they're like, I don't have evidence. It's just a vibe. Like, let me go talk to my other girlfriends and see if they feel the same vibes. They're like, yeah, I think Ray, did that type of thing. And then it's like, yeah, see, all of us are vibing. We think that you're a bad person. It's like, chill. Like, what evidence do you have? I was like, we don't. We just have vibes. Hold up. This is crazy. This is interesting. Wow. So a little bit of background here. So Elon Musk co-founded OpenAI in 2015, and the founding members are Sam Altman, Greg Brockman, and the OpenAI nonprofit organization. So the lawsuit alleged that OpenAI basically deviated from this mission by forming a for-profit entity and prioritizing commercial interests over its original altruistic goals. So Musk's complaint basically highlighted several key points here, and that's OpenAI's transition to a for-profit model in 2019, as we saw. The allegations basically that OpenAI had become a closed source de facto subsidiary for Microsoft, and the claims that OpenAI basically failed to provide Musk with regular updates on the company's progress and financials. So that's interesting. So OpenAI is like, yo, we are denying this because there's no formal agreement, as Musk has described. So the company argued that Musk's lawsuit was based on a collective understanding rather than a binding contract. So this is basically the vibes. It's like, do you even vibes, bro? OpenAI also released emails suggesting that Musk had initially supported the idea of creating a for-profit entity and to generate capital for building an artificial AGI. Yo, this is crazy. And so basically today, Elon Musk withdraws this contract and decided to drop the lawsuit without prejudice, meaning that he retains the right to refile it in the future. So the decision to withdraw came just before a scheduled hearing to address OpenAI's motion to dismiss the case. So the reasons behind Musk's decision to drop the lawsuit is unclear, but it may have been a strategic move to avoid further negative publicity or to resolve the dispute privately. Damn. Damn. Yo, this is major. So there's no such thing as bad media, right? Think of the echo chamber he created. How many people gave up on OpenAI and will come back to X's Grok? That's a very great point, Joshua. Like, I think that's one thing that sort of people, I don't know, like that, not that they won't forget, but I think I forget sometimes that he has this thing called Grok. And Grok, if those who don't know, is currently running on X, and it's basically a language model that's available for you to use, except it's not really that helpful. It's like really, really bad. It's probably for me worse than like GPT 3.5. And when I use it, it like totally makes stuff up. It's like not really that useful yet. And the team is working very hard to train the model and do these types of things and collect a whole bunch of data. And they have a bunch of data that they have available from Twitter. And I think one of the things that, to me, as I'm learning about these things, is the quality of data that you collect is going to be very important for the type of outputs you want. And like, it's not really clear yet what Grok's mission is, G-R-O-K, that's Grok with a K. And like what they're trying to achieve. Are they trying to be on par with ChatGPT to be like something that's available, or are they trying to deliver like new specific things that's like Twitter related? That's not really yet very clear. But Elon Musk doing these types of media events where he like starts a lawsuit, and sure, it costs him money, but when you're like a multi-billionaire like him, it is really kind of pennies. It causes a lot of stir. It causes a lot of media hype. There's a lot of technical details that people aren't well versed about, so they're trying to figure out and simplify things and spread a very simple message. And so then you get a lot of like, not misinformation, but you just get a lot of people echoing the same ideas around. And that's, to me, isn't a really helpful discourse. And that's kind of why I'm doing live streams. It's like, hey, let's learn together. I'm tired of like watching the same echo chamber of information when people don't really look for information. So let's just like dig right through, we can figure this out ourselves. We're all humans. We have literally these tools that are supposed to change the world. So why don't we use them to educate ourselves to change the world? I think there's the biggest myth for me that like people say that AI or AGI is going to take over very soon. And I think that's very, very far away. I think very far away for me, it's like a decade. And even if that is still going to require a lot more infrastructure and things that are going to need to be taking place. So, I mean, a good example from looking back in history and just is like the internet. Like if you had internet, it still took a very long time for things like Shopify to come out to help people sell stuff on the internet, and like PayPal and various things. There's just so much that needed to happen legally, like setting up shops, like the actual shipping. I mean, there's just like so many layers, and AI is kind of the same way. There's so many different layers that need to happen and infrastructure in between just to make them even run like, efficiently and do interesting things. And, you know, Apple's tackling that problem very specifically for their devices, for their users, for very specific tasks. But to do something else, you know, it's going to take the similar amount of engineering and effort. But once that's done, you know, you can build then on top of that. So that's kind of where it gets really interesting there. So yeah, definitely. Thank you, Joshua, for that insight. And also, yeah, thank you, VM, for dropping the breaking news that Elon Musk drops the breach of contract lawsuit against OpenAI. I think that's really interesting. It's very telling. Yeah, this is like pretty big news and stuff. So like, yeah, let me see if I can get back. And so somebody was also saying that the price of Apple stock, let's see, AAPL. What is the damn? Wow, 7% up? That's heavy. Let's go. Oh my God. Oh my goodness. Oh my god. Wow. Wow. Okay, Apple. Okay. This is the highest, I think, of all time. Yo, this is nuts. This is the highest of all time. Okay, so can we do, let's see, I started in 2010. Gosh, let's see. Yeah, right around this time. Before that. So since, and then, wow. 2,219%. That's absolute bonkers. Wow. So the last 5 years, being like a FANG employee, if you're like a FANG employee like at Apple, whatever shares you have are now worth like 3x. Gangsta. Not to mention the other shares you'd get just being there. I mean, Jesus Christ. Yo. Okay. So like compared to just a month ago, like they're up 11%. That's heavy. Warren Buffett is chilling right now. Okay, let's go to Tesla. Yeah, somebody talking about Tesla. Oh, they tanked today, 1%. Okay. I mean, that's pretty much like they have these weird pops and drops, right? So 1 month. Yeah. Like 1% down 1 month, 6 months, relatively flat. Year to date, 31% down. Okay. 5 years, not bad. I mean, where are you at? Let's see. 1,000%. That's respectable. If you're like a longtime employee. Let's see, from like 2010. I remember getting shares back here, like in 2010. Jesus. 12,000%. That's crazy. That's growth. That's like growth. That's S-curve growth. That's absolutely badonkers. NVIDIA, where you at? Oh my God. NVIDIA, you've got the bag, 151% year to date. A month ago, you're up 33%. Okay. 1 year ago, 181%. 5 years, let's go. We got to do the 5 year. 3,240% 5 years ago. So if you were an NVIDIA employee 5 years ago, yo, the Lambos about to start rolling out. I want to be a car dealer right now and just be like, if you NVIDIA employees, I got you 15% discount. I don't care. I'm still making money on my Lambos that I sell to you. Let's go. Yo, this is crazy. What up? Yo, what's up? B91000 Meta. Oh yeah, let's do Meta. Okay, we have to do Meta. All right, let's see. Okay, hold on. Meta stock price. Okay, 5 days ago, let's look at the month. Meta, you're chilling at 8%. And then 6 months ago, Meta, you're up 56%. Let's go. 1 year ago. Okay. 87%. 5 years ago. Damn, that's a massive dip. 165%. Not as cool. Like 5 years ago, like if you were to throw the dice in 5 years ago, like the employee to be would is like NVIDIA. I mean, that's a bag. NVIDIA's got, you got a bag if you're in NVIDIA. Like if you started at Meta in like 2012, right now you'd be up like 1,000%. That's respectable. That's respectable. If you started at Meta at the height, like in let's see, right here in August 2021, and like you would have lost like 70% of your shares. If you like said, you know, in November 2022, and you're like, I'm going to leave this company. I've already down like 75%. That's crazy. Imagine your portfolio. Like you've got like $100,000 stock grant and all you have left is, is like 25K. You're like, I'm going to cash out. And then like, I should have held because now I'm up like 34%. Yo, that's crazy. See, timing is weird. I think the only thing I could say, just in my experience, having been in tech for like 12 plus years, is like, just don't sell and just keep buying everything. And the reason why I say this is a little bit more because of like Mark Andreessen. So Mark Andreessen Horowitz, one of his podcasts actually says that we're in such a weird time, but where basically you can sit down in front of a computer, type in some things, and you have literally an economic output of value. Like, you know, teams of people can sit down and like literally punch in words, like monkeys sitting down in front of typewriters and punching out, and it actually produces something of economic value. And now you can give instructions to a computer, like an AI system, which does its thing and then outputs value. So like if you have these systems doing these things that create value, it's not like well, is this just a one-time thing and then kind of slingshot down? If you've seen all these companies, they just keep going up and up and up, mostly, right? Like relatively speaking from where they started. And older companies, maybe like Salesforce and stuff like that, or like even like Oracle, like, let's see, Oracle stock. They basically just keep refining value forever. Like they take this thing that they've created and just keep making value and keep refining those things over and over and over again. So like Salesforce. Let me do max. See? Up and to the right. And so if you work in these companies, if you work at one of these, you know, Fortune 500s or whatever, and especially in the tech sector, and especially in an area that's actually currently, you know, developing and doing things, then, you know, you're part of this machine that's creating economic value for the world. And that will always be valuable until it's not, right? Until like in like some crazy catastrophe, and then like what's valuable is like getting water to, you know, your tribe. Like that's going to be the valuable thing. And of course you're not going to be like looking at stocks. You're going to be like, I need water to survive. And like, that's kind of survival mode. But like here, where like things like the whole world has kind of shifted into this technology thing. I mean, it's like literally like be patient, I guess. And, you know, for me now actually no longer being at these like companies and like being on my own, it's like, how can I invest in myself in the S&Me 500, right? Instead of S&P 500, S&Me. And if I were to just take X amount of money and then dump it into me, into my resources and learning, what kind of economic output can I put out, right? And what do I need to learn to kind of get that there? So Abdul Khan, are you a coder? Yes, I am an engineer. And by trade, basically, I wouldn't say I'm an advanced coder at all. The more time that I spent at Apple, the less coding I did, as one does, and was more of like a firefighter type of thing. And so I became more of a generalist. I became like a specialty of a lot of different types of projects and things, and got to go very low level and very high level, and got really good at like debugging and fixing things and figuring out where stuff's broken or doing whatever needed to happen to get software shipped. was kind of my specialty. And so all throughout the way, I played along with like firmware. I played along with like operating systems, kernels, and like then all the way up into like the UI level as well, and got to play around with that and understand how these like major systems work. So just recently actually developed an app called TruthTorch, so truthtorch.ai. And so this is actually a tool that I made to try to understand and help with dealing with people who like understanding logical fallacies and trying to figure out like if someone was making information up or was lying to you, would you be able to kind of figure that out or try to find misinformation? So what I ended up doing, if you visit the website, I'm going to put it back here now that I've logged in, is basically you can get like a Twitter post or like Barack Obama wrote this on Medium. So it's like thoughts on Israel and Gaza. And so you can basically put it in here and it does an analysis. And I wrote this with using Next.js. So this is I did a lot of client side stuff, but now I've been kind of doing a lot of server side things because I want to learn a little bit more about how that stuff works. And it seems to be the easiest right now to use, like OpenAI endpoints. Is like a lot of it's server based. So I'm learning a lot of web development right now on, like how do I ship and deploy apps? So I have some stuff on, I'm planning to do more live streams where I do maybe some more coding and just kind of taking things as it goes. So just, nerding out and doing these types of things. So you can see, so this is basically my app. So you put this in and it basically spits out like a summary of the article. It does an analysis of the tone. So it'll tell us like, is this person screaming? Are they fearful? Like what's their whole thing? And like how they're actually appealing to emotions for people. And then from there, we can see like, so this is like a very technical writing output. And for me, this is more of like a very back-end heavy output. So the goal is to take this app and then start putting them onto like actual AI devices. So if you had like a device that was on you, that would be able to in real time, parse the audio and then like start looking for these types of fallacies and then like start to alert you saying, hey, this person who's talking is full of and this is why, or like at the end of a conversation, when you go home and do an analysis, it can just start spitting out like, hey, that conversation with you had that person, they kind of speak very fearful, or like they also say these broad claims that they don't really have any support for. So you can start to like, imagine if you had like this wearable that you had on with you all times that was kind of doing this analysis either during the moment or after you go home. It could be super, super helpful. I also want to use this for the live stream. So this is a project I'm currently working on as well, where basically like during the presidential elections, I'll have a live stream going and I'll basically have like a little, like a score summary thing that would be coming out in each side. So for every type of claim that's made, I'll basically show you if it's using fear or if they're using pity, and then like whatever claim they make, if there's any fallacies in that claim itself. And then also any reasoning. So it would just be kind of something I'm still working on. But if you want to work on it with me, definitely hit me up on the DMs. I'd love to have any help. This is just totally, but you can play around with this right now. You just go to truthtorch.ai, TRUTHTORCH.ai. And then you could just log in, and it's free. Like I'm literally just giving you like the, access to this for free. It's like, and you can put it in like go to your favorite article or whatever, put it in and like, figure out, and it streams the answer back in real time, like super fast, right? Crazy. So that's my thing. I like to give to the world. And to me, AI is a really interesting space to do these types of things and the leverage you get from, playing around with these types of things and so forth. So, so I think, let's see. If so, can you make a playlist of videos of how to get into software jobs like this? Abdullah, I think, let's see, to get into software jobs, I'm probably like the worst person to ask because I don't have a lot of experience getting into software jobs. I literally got my job at Apple because I wanted to grind so hard and I was like super desperate because I grew up, in the Bay Area, but super broke and super poor. And so I was like hustling. I was like DJing weddings. I was like trying to do like photographing and doing anything possible to just earn some income. And then from there, what ended up happening is that I worked with like one of my bosses, and he actually also had a job at Apple. And he says, hey, anytime you want to work at the Genius Bar or whatever, let me know. You'd be a great candidate because you have a lot of like tech background experience. And at that time, I'd already done like a lot of tech repair. I used to work at Geek Squad fixing computers. before that, I mean, I used to go to like every person's house fixing their computers for free because I was not a business person. I was just very helpful. And I just like to help people anyways. But I still needed money, right, to eat. So that's how I got in at Apple, just by working at the Genius Bar. And then from there, I learned that even though you don't have a degree, they still hire people with expert, skills and experience and so forth. And at that time, the iPhone was just getting off the ground. And so there was a bit of a hiring freeze, but when the hiring freeze turned off and they started to do more hiring again, I was all up in like every recruiter's emails and had tons of coffee chats with tons of people by talking to friends of friends. And because I was already in the company, I was just already reaching out at any way possible. They had events called beer bashes, which allowed me to go meet other engineers and friends and people who knew other people. So I just used that as a way to just really, I mean, for me, I had nothing to lose and everything to gain, and I was broke. So it was just leveraging as much as possible. So, I mean, today, if I were to do this again, with the advent of AI, I would just basically start like coding like crazy. I would, start like, even if you don't know how to code, just pull up some Python, pull up an IDE, pull up something and just start like looking at these AI projects and saying, can I build something like what Ray just built with TruthTorch, right? Look for some live streams, look for some YouTube stuff, and start learning. And that's part of the reason why I'm also doing live streams, is because I also want to make this of like the things that I'm learning right now available for other people in the future, because I sort of wish I had this, when I was getting started in tech in 2010. YouTube was there, but it wasn't at the detail that it is today. There aren't like details on like, this new language just came out. Like, let me just tell you everything on how it works. I wish I would have had that. That would have been amazing. And then the other part of it is I had severe dyslexia, so I couldn't really read that well. I was trying to read and it just took so long. And I learned way more by example and by actually bugging people and to help me in person. So that's the other thing too. So that's kind of using everything you have resource-wise to go actually meet people in person. You would not believe how many more opportunities happen. And then if you're in the Bay Area or anywhere, there are different places to do events. So look up any AI events in your area. Just start going to talk to people. There are so many engineers who need help on their projects. Even though you're a beginner, just take it on. Like say, hey, I'm new to coding. I just got started. I want to help you with your open source project. Like I saw your GitHub repo and, just start cloning it and try to figure it out, right? Like, or start asking them questions. I'm like, hey, I try to make this change. Like, can you tell me how this component works with this code? And then they'll be so happy to explain it because no one really asks them that stuff. So like, that's your advantage. And definitely once you do that enough, you'll build enough like muscle to be like, oh, I'm familiar with how to read code now. I can like clone a project and I can start using it and I can start doing these other types of things. And you start getting your hands dirty, and then you could say you've contributed to all these projects. And as you go along the way, you start figuring out, oh, I need this tool to help me with this. Let me just write a quick script for this, or let me have ChatGPT help me write this. And together, like, if you spend some time to do that, you're probably not the only one with that problem. And once you put that tool out there, other people will find that tool useful. And then once they start using it, then you kind of start to become like, put that on your resume. And if you have enough of those tools in your tool belt, I can't tell you, if you walk into an interview, like how many people I've interviewed who like just have that grit. It's like, it stands out so much because I've interviewed so many people over like a decade. And to me, I could tell people who've like come from that background who just really want it, like that stands out versus like, yeah, I'm just here because I have to pay back a lot of debt and my parents want me to get a job, but I don't really care about working in tech. But like, just like, who would you hire? Right? Like, be the person you want to be. So I know it's a very long game. It's not like, hey, you do these things and you're definitely going to get in. It's just not that environment right now. So definitely, I appreciate definitely the compliments there. So yeah, it's just a little bit about background Pakistani. So how can I break into this stuff? Yeah. Work on help other people and stuff for. I want a tool. I want this tool as an inline rating on each tweet. Yes. You know what, Hassan? I should probably work on making that maybe a plugin. And the tool we're talking about, I think right now, is basically the TruthTorch thing. So it would be kind of cool. Like you just click a button as like a Chrome plugin and it'll just kind of do this rating on the tweet. I think that'd be really awesome. Yeah. So can you give me some tips on how to learn to code? Definitely YouTube, just tutorials, how to get started, Python. I mean, if you're in the AI, I would definitely say just Python. Like go get started, figure out Python, just the basics, how to get a project up. There's some good resources too. You can, I think, Replit Python is really good. So if your computer sucks, you could just use Replit as like a free online type of thing to get started. And there's like a bunch of code things there you can try out. But what's cool about Replit is basically your code is already running online on a server, and you hit play. And then like if you like it, you could even deploy it as a website, and it's already running, which is pretty awesome. Actually, I'm running my LLM calculator literally as a Replit app. So I have this calculator that would basically tell you what size model you can run on your device. And this is really running on Replit. Let me see if I can log into Replit so that you can see. But basically, all you do is just give it what type of quantization, like the model you're running, like whether it's like an 8-bit model. And if like my Mac has 64 gigs of RAM, I can run like a 60 billion parameter model on my thing. And it's like, yo, that's pretty awesome. So let's see if I can log in here onto Replit, and then I could show you the app, because it's literally written in Python, and I think I mostly had the AI write it for me. I just told it what I wanted as far as requirements and things, and then got some feedback from my friends in the online communities here. So let me show you the app real quick. So my app is here. So this is the Replit, and this is the development environment they provide basically. And so this is basically my app here on the side. Let me kind of open this up here. Yeah, so this is the code. It's written in Python. And there's this framework called Streamlit. So Streamlit will basically create the website front end for you. So what that means is that like you just define what words or what type of output you want in each section, and Streamlit will like generate the HTML for you, which is awesome. And for a tool like this, especially since it's like a quick and dirty thing, you really don't need to like optimize super crazy heavy for like tons of web traffic and stuff. It just can be very simple. And that's why Streamlit's really cool. I also find Streamlit very helpful because the language models know a lot about Streamlit and how to take your requests for information and like build little apps and stuff for that. So you can literally describe like, I want a function calculator for a Streamlit app that'll calculate, the size of the RAM for how much I need for like a language model. And then it'll start to basically just, for me, this is what happened. It just generated all this code for me. And so, yeah, it's basically set up in functions, the titles, the markdown, you could just use it in markdown, and programmatically, you'll just fill in the values based on what's happening there. So yeah, so if I select, I want to have an 8-bit model. So if I want to run an 8-bit model with 64 gigs of RAM, I can have, the 60 billion parameters, and then and we're talking about Apple's, they're talking about like 2 bits and stuff like that. So just telling you about that. So let's see. Do you have a Discord room where we can talk to you easier, or is it just a live stream? As of right now, it's just a live stream. I'm just getting started. I like to also spend a lot of time away from computers. So I do 2 different things. Part of the reason right now is that I don't have like a Discord community is because with Discord, there's just a lot of notifications and it's too distracting. And I don't necessarily want to spend my full time on a computer all the time or on my phone. Like when I go outside for a hike, I just want to put my phone away and like not pay attention to anything. Like no emails, nothing. Just go, be creative, and kind of be one with nature. I think that's really important to do no matter where you're at, just to be like disconnected and have that time to think. And also for me, it also removes the echo chamber of like being too plugged in and too wired. And that has come over time because I used to be very wired, very tuned into like everything and wanting to be connected all the time and wanted to answer every email. So that's something I've worked really hard to disconnect myself with. So that's something, I don't really do right now, but maybe like something different in the future that's not maybe so notification heavy, which would be good. But yeah, I mean, if you want, you can always send me a DM on X, on Twitter, basically. And, I'll try to answer it whenever I can. That's my way to get reached out to you. So let's see. Genius Bar to go. VM, I appreciate the comments. This is awesome. Yeah. Sweet. Let's see here. Just going through some of the comments here. People have been saying stuff online. So you have a Lenovo with Windows Virtual Machine. Yeah. If you can get Python, Python should be able to work pretty much on every computer. So that should be chill. yeah, so if you haven't had a chance to, like I was saying earlier, definitely check out rayfernando.ai, and then just drop your email there. And so we can stay in contact, because I like to do these live streams and I want to do more of them. And, your feedback is also very valuable. So from there, you could just send me an email and saying, hey, can you talk about these topics? And then I'll try to go over them. But for the most part, basically, what I'm working on right now is I'm like a tech enthusiast. I love tech. I'm also an engineer. I used to be an engineer at Apple for 12 years. And I spend a lot of time, right now learning AI and researching and trying to understand how some of these things really work. And so with when Apple does like announcements and stuff like that, because I used to be an engineer there, obviously I'm very curious about what they've come up with. And we'll also try to drop my insights here on the live stream. And as you see, we go into a lot of detail, but it's kind of cool. I mean, I'm learning. There's only so much I could do at one time. And to share this with you is kind of part of my bigger mission to help other people who maybe don't have that advantage, who weren't in this area. And I've been very privileged to have been an engineer there for 12 years, having started from nothing to being working on the ground floor and being involved in some amazing projects there. I'm just super thankful. And to have this ability to just share this back with you, it really means a lot. And it means a lot for me that you're even here online. It looks like I have like 200 something people watching the stream. I was not even expecting that. So I'm just starting out as a creator. And I feel like this is my mission, to connect with you, to share what I know, and to connect with you as well. So definitely hit me back, at RayFernando1337 if you want to like the details there. So at RayFernando1337. If you're on YouTube, definitely subscribe. I also have a YouTube channel as well. I should put my YouTube channel on my website, because I don't think I actually have it on there. So yeah, I have videos here about AI and stuff. And I also I like tech products. So definitely we'll be taking a look at those. And you can see my review about the Human AI pin, and also about this other tool called the Friend, the wearable. And that's kind of where I was talking about Truth Torch and how I want to, if this Friend wearable is able to record stuff, get that input back to you, as far as like a summary. I also like to interview AI founders and people doing cool stuff in AI, because I'm in the Bay Area. I can reach out and walk up to people with my camera and just start recording. So definitely stay tuned. Crew AI is a really popular framework for agents, and we'll have to get into that a little bit later, because I also like to do a lot of tech tutorials. So we're going to do some stuff about prompting, and I can show you how I prompt, as you got a little bit of that and how I was using ChatGPT, but I really go deep on that, and how I use it for coding and so forth. So, hey Hanley, what's up? How's it going? Where's the tip jar? I don't have a tip jar yet. This is free. This is totally free. If you're joining the live stream, my tip jar is basically, if you hit the like button, if you hit subscribe, like that's actually huge, because it basically tells the algorithm that you're on the same vibe, and if you're vibing, you're gonna get more stuff like it. So why not? If we're vibing together, I definitely appreciate that. Yeah. So Crew AI, I think you took it once ago. Nothing better than educational material. Yeah, for sure. Yeah, definitely appreciate that, Hanley. Hanley is awesome. So if you're not familiar, Hanley is also a buddy of mine that I actually met recently, who also used to work at Apple, which is cool. So if you haven't, let me see if I can Google Hanley Young. Am I going to find the right things, Hanley? Yeah. So Hanley does a lot of stuff with Vision Pro. So definitely go check him out. And like actually he just talked about Vision OS. So he installed Vision OS 2.0 on his Apple headset, the Apple Vision Pro. And he has a video on here, if you haven't seen it yet, that basically turns the flat images into 3D, and it just is talking through his experience. He also has a podcast and stuff with some other buddies of his, where he talks about various things about, like Vision Pro, and like just giving his feedback and stuff. So he's got a lot of other tech things in there that I think you'll find entertaining. So definitely appreciate it. Yeah, definitely thanks for the follow and the heads up there. So I think with that in mind, it's about 3:11, and what I'm actually going to do right now is I'm going to get ready to head over to an AI event that's happening in Palo Alto. It's called the AI Tinkerers event. Let me see, AI Tinkerers. And so what's happening here in Palo Alto is basically there are a lot of people who are into AI, and they're not like actual investors or anything. They're literally engineers just like me. And yeah, just not enthusiasts. They're tinkerers. So they actually are building stuff either with hardware physically, or with software. And what's cool is that these people meet up in all basically Amsterdam, Berlin, Chicago, Fort Wayne, Seattle, San Francisco. And this meetups, they're very curated. So they only have 50 attendees. That's it. Like you have to make it or not. And so I just recently got added in, which was like super huge. And I'm planning to do a speech there next month, but I'm going to go check it out because the presentations are about 5 minutes. I'm actually going to bring my camera and I'll do a recording. So I'll definitely have a video going to be dropping on YouTube, probably like later next week or so after, summarizing this event and also getting to meet some other founders and talking to them directly about what they're building, why, and so forth. So here it's just like, to me, gets the early computer club vibes of people who are doing stuff and then passing on what they know and so forth. So yeah, definitely. So I'm going to get ready for that event because the doors open at 5 and then the demos go for an hour, looks like. And then there's like a networking part afterwards. So then an 8 o'clock wrap up. So this is the last event I think that happened here in Palo Alto. And these were some of the demos here. And I think one of my buddies was in this as well. So yeah, that's going to be a really fun event. So if you haven't had a chance to, definitely, follow me at RayFernando1337 on X and definitely on YouTube as well. Subscribe and I'll see y'all a little bit later. Thanks for following along. Definitely appreciate it. Keep it 100.